Hi all, I'm Brian,
And I'm Ray.
and this is another edition of Two Skis Walk Into a R.
Correct. And this one's about using the vegan package to do some diversity calculations. And we have this wonderful beetle diversity data set that I was introduced to only today. And we got a picture of a beetle on here just to,
Little flare.
little flair. But Brian knows about this data set. Can you tell us about it?
Absolutely. So this is going to be a ground beetle data set where we are going to have pitfall traps put into 3 different habitats.
Edge, grass, and wood?
Yes.
All right.
So as you can imagine, grass here is going to be a pitfall trap in a grassland habitat. And there's going to be 6 different sites within that grassland habitat.
So kind of 6 replicates.
6
maybe.
replicates,
Yeah.
yep. Where we are going to be collecting these beetles.
Nice.
We also have woodland habitat. So
Okay.
we have these little pitfall traps put into woodland habitat. And then we have this transitional zone where we have this edge. So between the grassland and the woodland, there's kind of a shrubby, edgy, transitional, scrubby space.
Full
And
of elves and gnomes?
I would think not, because they're mythical creatures, but we
Okay.
can pretend if we like.
Sure, great. Okay.
I would
but
also
there's
think
some beetles at least.
there's a whole bunch of ground beetles.
Okay, cool. All right, and then I assume this is the vegetation height in that spot, and this is just an ID for those different replicates. So we really care about this habitat as a predictor. And then I assume these are all different beetle species?
Yep, so these are going to be different beetles that were identified with extracting DNA and then running it through and identifying the beetles based on the DNA extraction from each of those beetles.
Last question, where in the world did this come from?
This is a data set drawn from the British Isles in England.
We'll avoid making Beatles jokes. We did all that already, so we're done. Okay, so
Are we?
Yeah, no. Well, we'll see. We'll see how it shakes out. So I already did the file download, comma separated values, and then I went over into our friend R, and I did that. File dot choose me, and found the file path. That's our Simpsons reference. You know that one?
I don't.
Okay. Look it up.
Oh, actually, I do know what that one is. It took me 5.
It's pretty good. So anyway, so we've got the file path in there. We've got strings as factors equals true, which is fantastic. And so I'm going to run that line.
Where can students find this data again?
Oh, yeah, right here. http://envs-capital Beatles. And I'll put it in the comments or something like that if I'm feeling sufficiently sophisticated. So now you can see those data are in there. That looks great. And then we're gonna get the structure on this. You can see we've got so many, and these are all integers, which is a kind of number, which is wonderful. And habitat is a factor, which is what we want. So this all looks great. And so now I'm still in the conditioning data frames part, so I don't even actually need, I'll do like a vegan diversity stuff, but it's still within the conditioning data frames bit.
Ray, do you know what vegan stands for?
It stands for vegetation something.
Vegetative analysis.
Oh, vegetative analysis. Okay. That's easy. All right. And and I just recently moved to Uptown, and it has Chicago's largest vegan mall. There's
cool.
a lot of vegetation analysis in there. But I'm going to do library, and I've already downloaded, installed vegan, so I just need to get it into working memory. And so now I've got the vegan functionality. That's wonderful. Okay, and so if I go over to the follow along, you'll see that there's, vegan's not going to work with this data frame because it's got missing values. We're going to deal with missing values in a minute. It's not going to work with this data set because the habitat column contains strings, and that's kind of the situation that we're in here with this beetle data set. We got a habitat. These are strings. Like vegan's it's just not going to work at all. So really, what we need to do is create a new data set that's going to just take the actual beetle data and nothing else, because what vegan really wants is just a data set of taxa, columns of taxa, rows of independent observations. And so we need to do this.
So the most common error that students run into is they will keep in a column that has those strings. So most of the errors that we're going to actually see with this data are going to be those issues of just trying to run this data straight away versus actually doing this cleaning step. So this cleaning step is really important to have success with the analyses that we're going to run.
Let's have success. So whatever our data frame name is, and then this is rows to select, comma, columns to select, because we're using the square brackets. And so we're going to pick this off by choosing the first beetle column number, colon, last beetle column number. And we're going to do something like this. I'll even call it just species. That's really nice. So check this out. Go back over here. I'll call it just species.df, and that's going to be my beetles data frame. I'm using the bracket notation. I'm typing a comma because, and I'll leave this part blank. That's going to select all the rows. And then I have to figure out what columns I actually want. So if I go over here, and I got here by clicking on this guy, and I float my cursor, it says that first column I want is column number 4.
Mm-hmm.
Okay, so let's remember that. Column number 4. And then I think if I click this double line here, I can get all the way to the end, and that should be column 51. I also know it's column 51 because it's the last column, and it's telling me there's 51 variables here, which is another word for columns. Okay, so 4 to 51 is what I'm after. So 4 to 51.
Can I just interject, because there's always many ways to do things in R.
Yeah, please.
If we type in to either the console or into the script names of beetles.
Names of the data frame beetles. Okay, yep.
And hit enter. What this does is it lists all of the column names.
Look at that, yeah.
And you can actually then count from here.
1, 2, 3, 4. That's the one I want.
And then down to 49, 50, 51.
All right.
So it's just another little shortcut that I use that.
I love that. Okay, and never forget to save your work, right?
Absolutely.
Absolutely. So this is going to be vegan in R. Okay, and so now I'm going to run this line. And let's look at this and make sure it actually worked. I remember that was the first one, so I think we're in good shape. And we've got 48 variables, and that was the last one. So our code was successful, which is fantastic. So let's go back to the follow along. So we've picked that off now, which is wonderful. And then the next thing we need to do is replace the missing values with zeros. Right, we've got these missing values, and vegan is not going to be happy with missing values. And normally, we would never replace missing values with zeros.
Correct.
Just in general, that's a terrible idea, because a missing value is just a missing value. It's not like...
It doesn't mean 0, because 0 means something very specific mathematically versus a missing value, which is NA. But this is... using the vegan package and working with diversity, this will be an exception.
This is an exception because what we actually know is that, when somebody came along to acu.dub, that species, and they didn't find any in the first habitat, it's not that these NAs in this specific case actually mean 0.
Absolutely.
In this specific case. And so we will replace these missing values with 0. But normally a terrible, 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 terrible thing to do.
And can I just show why R has interpreted that as NA versus 0 very quickly?
Sure, how? What?
So
I don't even know what you mean.
If you pull up the Excel sheet where we're looking at the Excel data.
You mean this thing?
Absolutely.
Yep.
You can see in these columns there's blank information.
Yep.
So R interprets an Excel blank as NA.
Got it.
The researcher should have or could have
put
or I could have put 0 in there.
0, but they got too lazy.
Well, I agree.
Yep.
Because I wouldn't want to.
No, who would want to do that? Right.
So it's just an interpretation of R that this is another little caveat to why we know that this is not missing data. It's 0 data.
It's actually zeros. Right. Awesome. Okay. So to replace missing values with zeros, Yeah, this is hysterical for Brian and me at least. Okay.
Sorry.
No, it's good. It's just really good.
I just love that joke.
It's just great. Okay, so we're going to use this thing where we're going to use this function called isNa, which means is missing. And so check this out. We're going to go bracket notation is.na, and then we're feeding in the same data frame into that. So this is going to return a true for every cell that has a missing value, and we're going to replace those with 0. So let's run that, and we'll always verify that it worked. And now you can see all those missing values have been replaced by zeros. All the numbers that were not missing are still there. So everything looks good. Save my script. Fantastic. So this looks like exactly the kind of thing that Vegan is going to be super happy with. And so now, let's go back. And now we basically want to use Vegan to calculate, let's do species richness, Shannon's index, and inverse Simpson.
I think that sounds great.
And the crazy thing now is we're going to slap these columns back on the original beetles data frame, not the just species. So check this out. We're going to go beetles, and I'm going to make a new column called richness. I could have called it anything, like beetle richness. I could have, but richness, that's pretty straightforward. And then I'm going to use the spec number function from Vegan. You can tell it's Vegan because it's got that little Vegan right there.
Our studio is very helpful with these types of things.
It is. It really is. And we're going to feed in just species.df. I can't remember if this requires any other arguments.
I believe that's it, sir.
Okay. Yeah, that's that stuff. Oh yeah, here's all this stuff. Spec number. That's all there is to it. Okay.
Oh, I'm sorry. We do. Spec number does work. Yeah, that's correct.
Yeah. So check this out. And now watch. Beetles right now has 51 columns. When I hit run, if all goes well, it should jump to 52. And it did. And you can double check that actually worked. Click the 2 arrows. And now we've got a richness column down here, which is fantastic. Let's do Beetles $Shannon, and this function is diversity, and we'll feed it in just species. And now we need index equals quote Shannon. I guess technically we don't really need that, but it's
good. We do, because this is how you would call
okay.
Simpson as well.
So this is going to jump to 53, I hope. Boom, 53. Okay.
Excellent.
And then let's do Beetles $inverse simp. I like that. Diversity, just species, index equals inverse Simpson. I think that's right. If it's not, it'll throw an error. I'm just going to throw an error just to demonstrate. Oh no, it's like, oh, it's not an index. What are you about? Oh, how about that one? Let's copy that and paste it in there. And now it's going to be happy. This should jump to 54, and it does. And we can just verify that those guys are all actually what we think they are. There they are. Richness,
excellent.
Shannon, inverse Simpson. There's just one more annoying thing. Sometimes you will have a habitat where you didn't really find any organism. That happens, and we sometimes go to the dunes and it's just not much happening, and that's going to create an infinite value for the inverse Simpson, and so we just need to clean those out. And it's some gnarly code, but you can deal with it, you can handle it. This is it. We're going to take our data frame, we're going to ask what values are infinite in the rows. We're going to identify the column that we're actually using, and we're going to assign a missing value to any of those infinite values. So let me see if I can do that. I may have to take another peek. Beetles, and then bracket notation is.infinite. And what are we asking is infinite? Beetles $inverse Simpson. Like
Absolutely.
that we're asking for where those rows are. And then this is where it gets confusing. We're also indexing the inverse Simps column. Woo! That's kind of gnarly, and we're going to replace any infinite values that it finds with missing values.
Sounds great.
I hope so. Yeah. Okay. Fantastic. I don't think there were any infinite values in
No.
this case, but good to be complete. And so now at this point, folks, it is as if you were handed a data frame that had everything you needed for your analysis. You can now treat your Beatles data frame or whatever you called your data frame just as if it got handed to you, ready to rock. So if you're like totally down with ANOVA, then you could probably stop this video right now. I'm gonna quickly run an ANOVA on, let's say, richness.
I think that sounds good.
Okay, so ANOVA of beetle richness versus habitat. And I'm going to copy paste adjust from the iris ANOVA that we did in our earlier video. I'll start here with the hypotheses and we'll go through all of this stuff. So I'm going to copy and then I'm going to paste, and then we're going to carefully adjust because there's going to be a lot of changes here. So at the population level, the mean, we're going to say beetle richness is the same for all three habitats.
Excellent.
Or the mean beetle richness of at least one habitat is different from the others. Okay, and the data frame is now beetles. So I'm going to change that to beetles, 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 beetles.
Got a good beat to it.
Beetles, beetles.
Maybe a backbeat.
Beetles, beetles, beetles. I don't see, beetles. Okay, there's a lot of beetles. And now I got to change my column names to something appropriate, such as richness. So that's going to be my response. Replace those guys, and now my predictor is habitat. I'm going to copy that, paste anywhere it says, oop, that was not good. There we go. There we go. There we go. Where else? Right here. There we go. I think that's right.
Looks pretty thorough, but we'll go line by line.
Yeah, we'll go line by line and make sure. So now let's visualize our data. Whoa! Yeah! Okay. So not as much replication as the iris data set, we got to say. So, but this seems like it'd be unlikely to get these data, assuming that in actuality at the population level they're all the same. Let's create our statistical object.
And this is Ray's first time looking at this data set.
This is literally this is hot off the presses.
Hot off the presses.
Okay, and then, oh my gosh, yes, this is our p-value. So this is saying that the odds of getting these data, assuming there's no difference at the population level, is like 2 times 10 to the minus fifth, which is quite significant. And then I'm just going to run the cooler agricole, so library, agricole. On that. Okay, now I can use this cooler post hoc test. ABC. Okay, so they're all statistically significantly different from each other, which is lovely. And now, if we recall our ANOVA workflow, we've plotted, we've created our object, we've gotten the output, we've done our post hoc, but now we have to verify that our p-value is actually valid.
Absolutely. Every time.
Yep. And the fact that I name everything M really helps me out in this case because all this code is just going to work. So that looks pretty normal to me. That looks decent. I mean, it's kind of falling off here and kind of falling off there, but not terrible. And now Shapiro test, we really quote unquote want it to be greater than 0.001. So what is it? Oh yeah. Oh my gosh. 0.96. That is super normal. Okay, and now we want some homoscedastic data. Ooh, ouch.
That's not looking as good.
That's not looking as good. That looks like the variation here is much smaller than the variation in these others, but these are smaller sample sizes, so sometimes this is a little deceiving. Not this. Ooh, it just barely didn't cross our line. Just barely didn't cross our line. Remember, our line is 0.01. And it's slightly smaller, and so we would say the variance is not equal among groups.
But lines exist for a reason.
Yeah, I know. Like the reality is that it's on the line.
It's on the line.
But let's play the game. P-value is not valid. Let's see if we can't transform this. I'm gonna try. Square root's a real fun one to try, and off mic, Brian just gave me a thumbs up. So That's always a good sign. I don't know what's going on in my mouth here. Okay, all right, here we go. So we're going to do a square root. I'll do it the old-fashioned way, the way everybody loved to do it. Square root, parentheses, parentheses, even though I don't normally do it that way. So now that transformation exists inside there.
Mm-hmm.
Let's see if we pass our test. That looks normal. That looks good. That looks good. Shapiro's still as happy as what do they say, clam? I don't know how happy clams are, really. That doesn't look appreciably better, but it gets us over the line.
Gets us over the line.
By a fair bit, actually. So now we've met both of our assumptions. Let's make sure that our output still is, that our p-value, p-value is going to change a little bit, still statistically significant. Let's go back to our raw data. That's the place to be when you're looking at your actual p-value from the ANOVA. And then let's just make sure our post hoc, nothing's changed there. ABC. Yeah, they're all still statistically significantly different from each other. I think that's it, man.
Yeah, so as we think about this, I know that we went through the ANOVA quickly, making sure to watch these videos in the recommended order of ANOVA without transformations, ANOVA with transformations, and the linear regression will also help you as well.
Yeah.
And then capping it off with this video is, at the end, pretty important to do.
Great.
So if you were confused, go back to the beginning.
Hope you did it that way. Okay, maybe I'll try and make some comments that will direct the students in a useful way. Saving my script. Let's stop the recording.